Welcome back. Catherine Morgan-Nance here to chat with you about a very important financial concept, the time value of money. As I noted in an earlier video, most managers understand that a dollar today is worth more than a dollar in the future. Time value of money techniques acknowledge the compounding nature of interest earned or paid on an investment over time. When evaluating a potential investment, managers discount future cash flows to determine their value in today's dollars, their present value. We will cover the net present value approach to capital budgeting in the next video. Before we do so, it will be helpful for you to understand some basic discounted cash flow terminology as shown on this slide and the next. First, we assume cash inflows and outflows, called principal here, bear compound interest. Remember that interest is simply an expected return on money invested. Compound interest is interest earned both on the initial amount invested, the principal, and on the interest being earned. Compounding interest provides a higher return than interest earned on principal only, simple interest. Second, cash flows may occur at a single time, such as the initial investment in a project or the collection of a lump sum of money sometime in the future. Alternatively, cash flows may occur in regular payments over the life of a project, as an annuity. An example of an annuity is the payments due every month for a car loan. Another example of an annuity are the operating cash flows received during the life of a project. Notice that the words annual and annuity both have the first same four letters. They come from the same Latin word for year. So if you see the word annual or yearly in an example, you will know that it means annuity. The present value of an amount is the value today of money received in the future. We assume the money is invested at a specific compounding interest rate for a certain period of time. Future value can be thought of as the opposite of present value. In fact, present value and future value are like two sides of the same coin. Future value is the amount we'll receive sometime in the future if we invest money today, the present value bearing compound interest. If you have not studied the time value of money and present value concepts previously, I recommend that you watch the Khan Academy video at the website provided on this slide. The first 5.5 minutes of the Khan video are especially relevant to our discussion. Please note as well, we will use the standard present value tables rather than developing present value formulas ourselves. I've provided you with present value tables. However, you can download present value tables from several websites. One such website link for an Excel file is provided on the screen. I will show you the two present value tables we will be using in a moment. Then we will look at examples of how to determine the present value of an amount. Present values are usually calculated using financial calculators or formulas set up in an Excel spreadsheet. However, for simplicity purposes, we will use published present value tables to calculate present values. The results will not differ from the calculator or spreadsheet approaches. Present value tables are designed using a matrix of interest rates and a number of periods over which payments may be made. A present value factor is found at the intersection of each rate and period. Present value tables provide a very easy way for us to calculate the present value of a single amount or the present value of an annuity. Please make a note of the following tip. The present value factor for an amount invested today is 1. That is because the present value of a dollar today is a dollar. No time has passed for interest to be earned. The first table we will be using is the present value of a single payment table. A single payment may be as simple as electing to receive lottery winnings in the future rather than today. In business, a single payment may be made at the beginning of a project for the initial investment and working capital, in the middle of the project for maintenance or upgrades, and at the end of the project for salvage value of the used up assets or recovery of working capital. The table is set up with a series of discount rates, interest rates across the top, and a number of periods down the left-hand side. To locate the appropriate present value factor, you'll simply find the intersection of the project's rate and number of periods. For example, the present value factor for a 5% discount rate for 5 periods is 0.784. Also notice that the factors in this table are less than 1. That is because the present value today of $1 received in the future is less than $1. Remember, the present value factor for an amount invested today is 1. As discussed previously, an annuity is some sort of an investment that involves a series of identical cash flows at the end of each period, assuming compound interest. In our examples, a period will be 1 year. Examples include payments on a mortgage, a car or equipment loan, a lease payment, and an investment in a whole life, not a term, life insurance policy. You can also actually purchase a type of retirement investment called an annuity. Please search for the term annuity on the internet if you would like more information about annuities. The second table we will use is the present value of an annuity table. An annuity is an equal payment that is made at the end of equal intervals, such as amounts paid under an auto or mortgage loan. This table works the same way as the single payment table, but is used when the payment is an annuity. Notice that most of the factors in this table are greater than 1, other than in period 1. Multiple payments are being made over time, so the present value of an annuity is greater than 1, but something less than the number of periods over which the payments are made. Here's a quick illustration. What is the value today of $100 received 2 years from now? Assume the amount is invested for those 2 years at 12% interest. So you'll use the present value of $1, a single payment table. Using the present value table for a single payment, locate the present value factor at the intersection of the column for the 12% rate and the row for 2 periods. The appropriate present value factor is 0.797. Multiply the payment of $100 times the present value factor of 0.797. The present value is $79.72. In other words, if you invest $79.70 today at 12% interest, it will be worth $100 in 2 years with compounded interest. Now suppose you have a winning lottery ticket and the state gives you the option of taking $100 3 years from now or taking the present value of $10,000 now. The state uses an 8% rate in discounting. How much will you receive if you accept your winnings now? Using the present value of a single amount table, we locate the present value factor at the intersection of the 8% interest rate column and the 3 periods row. It is 0.794. Multiply 0.794 times the future value of $10,000 and you will be able to determine the present value of cash winnings to be $7,940. If you thought you could invest those winnings today and earn more than 8%, you would take the $7,940 rather than wait to receive the $10,000 in 3 years. Now let's look at a couple of annuity examples. Assume that you will receive $1,000 cash annually for 3 years at a time when the discount rate is 10%. What table do you use? That's right, you use the present value of an annuity table and locate the present value factor in the same way as you did previously. The challenge is to make certain that you select the correct table. The present value of an annuity factor is located at the intersection of the 10% interest rate column and the 3 periods row. It is 2.487. Notice this amount is greater than 1 because there are multiple payments made in an annuity. Multiply 2.487 times the future value of $1,000 and you're able to determine the present value of the annuity to be $2,487. For our final illustration, Assume ABC Company has just signed an agreement to purchase equipment for installment payments of $6,000 each to be paid at the end of each of the next 5 years. The appropriate discount rate is 12%. What is the present value of the installment payments? Take a moment to calculate the present value. Did you pick the present value of an annuity factor of 3.605? If so, you determine that the present value of this purchase is $21,630. In the real world, the question you'd be asking is, what is the fair market value of this equipment today? What is the cash price, in other words, that we would be willing to pay for it right now? You'd only be willing to sign the purchase agreement if the fair value of the equipment is at least $21,630. Present value concepts can be very useful, don't you think? In the next video, we will discuss the net present value method of evaluating a potential project. See you soon.